Now, the next question states, the procedure remove data removes a node from the linked list. This a node is removed. This is not printing, but total removing. So removing means you remove the value and then you make it empty. And don't forget, empty means you replace whatever value that is there to -1. So the procedure takes the data item to be removed from the linked list as a parameter. So you have to pass a parameter, which is the value to be removed. The procedure checks each node in the linked list, starting with the first node, until it finds the node to be removed. So it starts to find the node to be removed. So the data to remove is passed as a parameter. Then you check each node to see if the node is there. Once it's found, then you remove. This node is added to the empty list. That is, you make it empty, and pointers are changed as appropriate. So you change the pointers. The procedure only removes the first occurrence. So if there are two values, just remove only the first occurrence. Assume that the data item being removed is in the linked list. So I ask to assume that the value you want to remove is in the linked list. So you don't have to check if it is empty. It is there. Don't worry. Write program code for what? For remove data. You cannot write this code except you go back to the previous code. Dry run it when you added, then after adding, then you now try to remove, because we have to remove according to the pointer. Don't forget, we are removing starting from the first node. Okay, starting from the first node. So first and foremost, let's define the function. So we know that the function is remove data, isn't it? Good. So I have def value, then the value to be removed. Then after this is done, then let's go back to that table to try out the data to be removed. So let's try different data. So before we do this, let's go back to insert data. I think you still understand how insert data works. So since you still understand, so let's add these values. Okay. So adding the first value, 5, you make this to be -1, right? Then adding the next value, 6, then this becomes 0 from the previous code we've written. Then adding 8, then this becomes and this becomes 1. Okay, it becomes 1. Then adding 9, this becomes 2. Then adding 5, this becomes 3, right? So that is all. 1, 2, 3, 4, 5. 5 values have been added. So that means this is now the first node. This is the first empty, which is equal to -1. That is the 5th index. Then 6, if you can still remember this. Okay, good. So let's now try to remove a value. So let's take, for example, we want to remove the value 5. So that should be remove data 5. Remove data, remove data 5. We want to remove the 5th data. Now, the first thing is to know the current node. What is the current node? The current node is equal to 4. The current node is equal to 4. This is the current node. Then you now check the value at the current node if it is the value you want to remove. That means you check if linked list, if LT means linked list, then current, then 0, which is 4, is equal to the value you want to remove, which is true, isn't it? If it is equal, what are you supposed to do? Then you make it empty, right? So that means that the left pointer, um, of current 0 must be equal to -1. So that is, you delete this, then you turn this to -1. Then don't forget that if this is -1, you also have to remove the pointer, because this means there is no value, right? So you have to remove the pointer so that it now points at it now points as what? At the what is it called? The first empty. Do you guys understand that? So that it points at first empty. So this is removed, the 3 will be removed. But before we remove it, please save it somewhere. You may need this later. So let's save previous to be equal to 3. That means if this is removed, then you make the left pointer of, that is previous will be equal to, instead of writing 3, write a linked list of current 1, right? So that the left pointer of current 1 is equal to the first empty. So that this will now be equal to 5. If this is 5, then this can no longer be the first empty. This should be the first empty, isn't it? So that means that the first empty must now be equal to the first node, isn't it? So this must be the first empty. Then we have to change the first node, right? So the first node must now be equal to this first node, which was the value we saved earlier. In what? In previous. I hope you understand this. So if you want to print this again, it becomes, you start from first node, right? Then it becomes 9, then points to 2, 8, points to 1, 6, point to 0, 5, and that is all. If you want to add a new value, you add it to the position of first empty, right? If you add it to the position of first empty, this now becomes the first node, isn't it? Then it points to what? Index 5, which should now be the first empty. Then you have to update this back to index 3. I hope this is well understood. So this works if the first value is the search value. I hope this is understood. It works if the first value is the search value, or if it is the value to be removed, it works. So what if we want to find remove data, let's say remove data 8. Remove data 8. So let me clean this. Then test if this works for remove data 8. So if you want to check it for remove data 8, of course, I said you should check the current node, right? So the current node should be the first node, isn't it? First node, which is 4, isn't it? So that means the current node is equal to 4, which is the first node, 4. So is the value you want to remove equals to the first item at the first node? That is, if the linked list 40 is equal to value, is it equal? The answer is no. That means all this will not be executed because that value is not the first value. So that means you need an else statement. I hope this is understood. You need an else statement that if it is not this, what if it is not this? Then your current value should now be 3. That is, since it is not this, you must find this. You must search for this. So to search for this means you need to go back to the point to where it is linked to. Do you understand? So current value should be equal to the linked list of current 1. Because current is still 4, don't forget, which is still the first node. It is still 4. So linked list of 4, 1. So that means the current value is now equal to 3. Then you search again. If you search again, because now you have to keep searching until it's found. So we can use while loop because you have to keep searching. So you can have while the value of current is not equal to minus. That you continue to search until it is -1. You can also write while true. So the value of current is 3. That means it cannot be -1. So you save. You can also write while true. So then you now check if what? The value you want to find is equal to the left pointer of current 0. That means, is it this value 9? Because that is 3, 0, isn't it? So 30 is 9. It is not that value, right? So since it's not value, then we have to go to else. Do you understand? We have to go to else. When we get to else, that means the value for current must be equal to this, isn't it? So else current is equal to linked list of current 1. So what does that imply? So if value is equal to linked list of 30, linked list of 30, it is not equal, right? So let's leave this space to write for the code when it is equal. Since it is not equal, then the current should be equal to 2, right? So that means that current should be equal to linked list of 3, 1. 3, 1, isn't it? And 3, 1 is 2. Since 3, 1 is 2, it goes back to the while loop, okay? It goes back to the while loop to check why current is not equal to -1. So since the value of current is not equal to -1, then it's check if value is equal to linked list of 2, 0. Now, no more 3. 2, 0. I hope this is understood. So linked list of 2, 0 is now 8. Linked list of 2, 0 is 8. So now it is equal. So now that it is equal, like I told you, you change this value to -1, isn't it? Like we did earlier. So that means that the linked list of current, current 0 will be equal to -1. That is, the linked list of 2, 0 is -1. So this is no longer 8, then it turns to -1. So if this is -1, we need to keep this 1 somewhere, right? So it's not lost. I can write VAR is equal to the linked list of current, current 1, right? So the linked list of 2, 1 is variable. That means the value for variable is equal to 1. Do you understand that? So the value of variable is equal to 1. It is not lost. Then I have to make this to point to the next empty list because it is now an empty list. It should point to the next empty list, which is 5, isn't it? So that implies that because of my space, that implies that the linked list of current, current 1 must be equal to first empty. So that means this is no longer 1, it is now 5. I hope you guys are following me. So since this is 5, so this should now be the first empty, no longer this. So that means that the first empty must now be equal to 2, which is still current, must be equal to current. So that is the first empty. So the value of first node is not changed because it still remains first node. So the first empty is equal to current. That means the value for first empty will be equal to 2, which is correct. So that means when the value is added here, then it points to 5. 5 will now be the next first empty. So after this is done, don't forget that this value 2 must now be equal to 1 so that node 3 points to node 1. So this value 2 must be equal to 1. Don't forget that it is still current, right? Current is still equal to 2. So that implies that the linked list of current 1, the linked list of current 1, no, no, not linked list of current 1. So because current is still 2, we are supposed to take the previous value, which was 3, this value. So we lost track of this value. We never kept it. We never kept it when we were doing the loop, if you remember. Because if I would link this of current 1, current is still 2. So link list of 2, 1 is still 5. But I was supposed to change the link list of this one, which is 2. So that means before I take the new value, I must always keep that value into what? Into a variable. I hope this is understood. So that means before I move on, I must have another previous, okay? Because the previous was only if the value was the first value. After that, I no longer needed it. So I need to create another value, another variable for previous to keep the previous value before I start again. So previous will be equal to current. So that I need to do this before. I think this needs to change. This needs to change position. This should come after. So that before, remember this was initially 3, 1. Then I keep the previous in current so that the value for previous will be equal to 3. Then 3, 1 will be equal to 2. So I need to keep previous to current, then that will be all. So at the end of the day, then I will have been able to change this value from 2 to variable. Okay, so that means that the linked list of previous one is equal to variable. So I hope this is well understood. So let's write the code now. The full code now can now be written. Um, so let's start from when the value is the first, the search value is the first value. That is, the value to be deleted is the first value. So that means we have to have current is equal to first node. Okay, current is equal. That's why it's good to plan your code before you start typing to prevent making mistakes. So if linked list current 0, so if linked list current 0 is equal to the value, the parameter pass, the value to be deleted. So linked list of current 0 is equal to -1. So the linked list of current 0 is equal to -1. Is equal to -1. So I have to hit 1 equal. Now, then previous is equal to linked list of current 1. Then previous is equal to linked list of current 1. And linked list of current 1 is equal to first empty. The linked list of current 1 is equal to first empty. And first empty is equal to first node. First empty is equal to first node. And first node is equal to previous. First node is equal to previous. That is if it was the first value, right? But what if it is not the first value? Else, if the search value is not the first value, then we take the current value. So current is equal to the linked list of current 1. Current 1, no longer the first node. Then why current is not equal to 1? Why the value for current is not equal to -1 rather? If value linked list current 0, if value is equal to linked list current 0, so let me do this. If value is equal to linked list of current 0 is equal to linked list of current 0, if value is equal to linked list of current 0, linked list current 0 is equal to -1. So the linked list of current 0 is equal to -1. So I need to put this in an indentation. The linked list of current 0 is equal to -1. And variable, like I said earlier, you keep this to a variable. So variable is equal to linked list of current 1. The linked list of current 1. Variable is equal to linked list of current 1. Then else, no, before else, the code is not over. Then linked list of current 1 is equal to first empty. So linked list of current 1 is equal to first empty. And first empty is equal to current. First empty is equal to current. And the linked list of previous one is equal to VAR. The linked list of previous one is equal to VAR, is equal to variable. So else, then I have current is equal to linked list of current one. Current is equal to the linked list of current one, and then previous is equal to current. Previous is equal to current. Yeah. So let's run this code to see what the result will be. Okay. So now let's run it. So the first set of value is 56895. 56895. No, no, that is not all. I need to call the function, isn't it? So let me go back to the code. We are asked to call, where is it? You are asked to call remove data with parameter 5. Okay, good. So we need to call remove data with parameter 5. Okay, we have to call remove data with parameter 5. Then output the word after. So you print after and call output linked list. So output linked list. So now so that means 5 is needed to be deleted. So let's run the code now. So now we run the code. So the first set of value is 56895. 56895. Okay, good. So let's see the problem. Current is equal to first node. Uh, cannot access local variable. um, Cannot access local. Yeah, I did not initialize. I did not declare the global variables here. So I need to go back just to copy my global variables, then put it down here. Okay, so good. Then run your code again. 56895. 56895. Yes, let's take a look at this. 56895. 5689. Oh, 59865. It should be 5986. So the first value has been deleted. So which is fine and which is correct. I hope this is well understood. So the first value is 5. It has been deleted. So we still have 9865 left. So which is correct. So let's take the second one, which is 107856. There's one again. With 107856. Yes, let's see. There's an error that says linked list previous one is equal to cannot access local variable preview. Let's see. Previous cannot be accessed. I think it should be this point. Let me run it again to be sure. 107856. 107856. Okay, good. So previous one, that is line 52. Yes, line 52. It's very possible there is a problem. Why? Because if the value is not the first value, then at this point, if it is the second value, the value of previous is used for the first time, that is unknown. Okay, so the only option I have now is, so since this value is appearing here for the first time, and we needed the previous value, that means I need to come back to this code if it is the first value, take the previous out of this if statement, then put it here. I hope this is understood. So that the previous value has been kept as the value of the next node before it starts here. Okay, so let's run this code now to check that. And this is 107856. This is 10, 7, 8, 5, 6. Okay, good. So let's see. So the first value is 6. The second value is 5. You can see 5 has been deleted. But the issue is 5 is not supposed to be printed. It's an empty value. It should just be 6, 8, 7, 10. So I don't think -1 should be printed. So the only thing we need to do is find the reason why -1 is printed, then we remove it. Okay, so let's dry run the code to see the reason why -1 is printed. So apart from -1, the second value, which is 5, has been deleted. So only that empty value was printed. So let's see what is wrong. So let's check this code to see where the problem is. Now, this is the value and these are the pointers. So let's start. Current is equal to first node. The value for current will be equal to the first node, which is 4. Okay. So the value for current is 4. Then previous is equal to linked list of 4, 1. So that means the value for previous will be equal to linked list of 4, 1 is 3. So previous is equal to 3. I hope this is understood. Now it states that if linked list 40 is equal to value, is equal to value, so that if statement is false, it is not equal to 5, right? Good. Since it is not equal to 5, then we'll move to the else statement. So what is now the value for current? Remember, previous was 3. What is the value for current? 4, 1. The value for current is now 3. Okay, current is now equal to 3. Since the value for current is equal to 3, it's also saying current is equal to previous, which is also the same, isn't it? So the value for current is now equal to 3. Then we said why current is not equal to -1. That is like while true, isn't it? So that is while true. So while true. So if the value is equal to linked list of 3, 0, the current is 3. Linked list of 3, 0 is this. Is the value equal? Yes, the value is equal. Since the value is now equal, so linked list of 3, 0 is equal to -1. So linked list of 3, 0, this is now equal to -1, isn't it? So variable is equal to linked list of 3, 1. That means variable is equal to linked list of 3, 1, which is now 2. Okay, linked list of 3, 1 is 2. Then linked list of 3, 1 is equal to false empty. Linked list of 3, 1 is now equal to false empty, which is equal to 5, which is 5. So this is now correct, isn't it? Now, first empty is equal to current. Don't forget current is still 3. So that means false empty is equal to 3. So this is false empty. So this is no longer false empty, isn't it? Which is correct. And linked list, okay, false empty is equal to current, which is 3. Linked list of previous. What was the previous value? The previous value was 3, isn't it? So linked list of 3, 1 is equal to variable. Linked list of 3, 1. Oh, linked list of 3, 1. So this is now changed from 5 to 1 again. That is the problem. It was supposed to be the linked list of 4, 1, which is equal to variable. It is this one that's supposed to be 1, not this one. I hope you guys understand the issue in this line of code. So instead of linked list of 3, 1, it should be linked list of 4, 1, because I want to change this 4, 1, right? So let me see what I need to do. So what I needed to do is, before I make this current to be equal to 3, I am supposed to have saved this 4 into previous, so that this value of 4 is not lost. So that means the only thing I need to correct is this line of code where I wrote previous is equal to current. This needs to leave this point, or Control C, then come here before writing current, then write previous is equal to current, so that the previous value is 4 before everything starts. So that previous value of 4 is kept. So this will solve the problem. I hope this is understood. So let's run the code now again. 107856. Then you run the code. Then this becomes 107856. Now you can see 6 is the first value. The second value 5 has been deleted. Then we have 8, 7, 10, which is now absolutely correct. So I hope this is well understood. So if you have any questions, you can ask in the comment section. Thank you for your time. See you on the next one.